NASA's James Webb Space Telescope, JWST, has only just opened its eyes to the universe, but it's already revealing mind-boggling phenomena that are making scientists rethink everything we thought we knew about the cosmos. Imagine someone suggesting that we build a telescope capable of peering into the furthest reaches of space, uncovering things that challenge our understanding of how the universe works. What if it could see the impossible, like rogue planets that shouldn't even exist, let alone move in pairs across the void of space? It turns out, that's exactly what the JWST is finding. These rogue planets are drifting through the vast emptiness of space, untethered to any star, defying the very laws of planetary formation. Normally, planets form by orbiting around stars like Earth orbits the Sun. But the JWST has discovered planets that have no star to orbit. These so-called loner planets are wandering through space, breaking every rule we thought we understood. What's even stranger is that many of them appear in pairs, moving together across the cosmos in a way that doesn't quite make sense. Why would these rogue planets pair up like this, especially when we're still trying to understand how they even exist in the first place? Scientists have a few theories, but none of them fully explain why these planets always seem to come in twos. One possibility is that these planets formed in regions of the Orion Nebula where there wasn't enough gas to make full-fledged stars. Instead, gas giants were born, but without a star to bind them. These planets may have been pushed out of their original solar systems by a massive cosmic event, but why did they get kicked out in pairs? Theories are still forming, but one thing is certain: the universe is much more complex than we ever imagined, and the JWST is showing us just how much we don't know. But rogue planets are just the beginning. The JWST is also observing galaxies that are defying expectations in equally baffling ways. For instance, it has spotted galaxies that appear to have formed just a few 100 million years after the Big Bang, fully formed and as large as our Milky Way. This is a discovery that challenges our models of cosmic evolution. Galaxies, it turns out, might have developed much faster than we thought, and understanding how this rapid growth occurred could change everything we know about cosmic timelines. This mystery has led scientists to consider new ideas about the formation of supermassive black holes, which could have played a role in speeding up the growth of galaxies. Could there have been mechanisms at play in the early universe that allowed galaxies to form more quickly than we ever realized? The JWST's discoveries are not just shaking up our understanding of distant galaxies, they are also throwing doubt on the very framework we use to describe how the universe operates. One possibility is that the expansion of the universe is being influenced by an unknown force, perhaps a new kind of dark energy or even a shift in the fundamental understanding of gravity. We've always thought we knew how galaxies and clusters move through space, but the JWST is showing us that there may be forces at work that we haven't even begun to understand. And then there are the rogue planets, once again breaking the rules of planetary formation. These loners could have been ejected from their solar systems, or they might have never been part of a system at all. But what's truly remarkable is how they tend to travel in pairs, defying all logic. Could it be that we're simply missing something fundamental in our models of planet formation? Could the Orion Nebula, for example, be creating pairs of gas giants instead of stars in a way that we hadn't anticipated? Until we know more, the answers remain a mystery. The JWST is only beginning its mission, yet it has already forced scientists to challenge their assumptions and rethink the very nature of the universe. Whether it's discovering rogue planets that don't follow the rules, or galaxies that appear far too advanced for their age, or even black holes that seem impossibly large for their time, the JWST is providing us with insights that could reshape our understanding of everything from the formation of planets to the origins of galaxies. Each discovery is another clue in the grand puzzle of the cosmos, and every new finding opens up more questions than answers. But that's what makes this journey so exciting. As we push forward, the universe is revealing itself to be far more complex than we ever imagined, and the JWST is showing us how much we don't know. The JWST isn't just a new telescope, it's a revolutionary tool that's showing us things about the universe we couldn't even have dreamed of. It has an incredible infrared camera that allows it to see through the cosmic dust, peering into the deepest corners of space. One of its key missions is to study exoplanets and their atmospheres, and it's already making some groundbreaking discoveries. For example, the telescope has studied the exoplanet WASP-39b, a gas giant located over 700 light-years away. When JWST looked at the atmosphere of this distant world, it found sulfur dioxide, a gas usually associated with volcanic activity on Earth. This was a surprise because it was never expected to find sulfur dioxide on such a planet. It appears that something in the atmosphere of WASP-39b is reacting with sunlight to create this compound, possibly through a photochemical reaction. It's the first time this type of molecule has been observed outside our solar system, and it's a discovery that could change our understanding of how planetary atmospheres function. But that's not all. JWST has also detected carbon dioxide in the atmosphere of WASP-39b, another first that gives scientists more clues about the planet's formation and evolution. And then there's K2-18b, a super-Earth located in its star's habitable zone, where temperatures might allow liquid water to exist. JWST detected what could be a trace of dimethyl sulfide in the atmosphere of K2-18b, a molecule produced primarily by life on Earth. Could this hint at the possibility of life on this distant planet? While scientists are still debating whether this molecule was really detected, the very possibility has sent shockwaves through the scientific community. Even if the molecule turns out to be of non-biological origin, the detection itself is groundbreaking and opens the door to new questions about planetary chemistry. JWST's observations are also pushing scientists to rethink how gas giants form and evolve. For a long time, we thought gas giants like Jupiter and Saturn formed in the colder parts of a star system, gathering gas and ice before migrating inward. But the JWST is revealing that some of these planets have atmospheres that are much more reactive than we expected. Molecules like sulfur dioxide are being influenced by stellar radiation, altering the chemistry of these planets in ways we didn't understand before. This new insight challenges previous ideas about how planetary atmospheres change over time, and it could have far-reaching implications for how we study planetary evolution. JWST's discoveries are not just exciting for what they reveal about exoplanets, but for what they tell us about the broader universe. The telescope's ability to detect tiny amounts of molecules like methane, water vapor, and carbon dioxide in the atmospheres of distant planets is revolutionizing the search for life beyond Earth. But these molecules are tricky. While they can be produced by living organisms, they can also come from non-living processes like volcanic activity. That means there's still a lot of work to do before we can be sure that life exists on these distant worlds. Still, the very possibility is enough to fuel the excitement. As the JWST continues its mission, it will study more and more planets, both gas giants and rocky worlds, with the potential to discover even more surprising and complex phenomena. The universe is proving to be far more diverse than we ever thought, and the JWST is just beginning to unlock its secrets. Whether it's gas giants with reactive atmospheres or rocky worlds with the potential for life, the discoveries are endless. With each new piece of the puzzle, we are one step closer to answering the age-old question, are we alone in the universe? As we continue our exploration, it's clear that the universe is full of surprises, and the JWST is showing us how much we still have to learn. Each discovery opens new doors, and with each question answered, more mysteries emerge. The universe is far stranger and more wonderful than we ever imagined, and thanks to the James Webb Space Telescope, we're getting closer than ever to understanding the cosmic story that's been unfolding for billions of years. The journey has only just